Hey everyone, today I'm going to be talking about integrating to find volumes as a part of the 2-unit mathematics course. I'll be showing you how to actually integrate to find the volume of solids of revolution in respect to the x and y axes. Okay, perfect. Let's go down to our first example. I've drawn out the general formula here, and it's basically pi to the integral of the limits y squared in respect to x. Perfect. So let's have a look at the question. Calculate the volume of the solid of revolution formed when the region shown is rotated about the x-axis. So it's asking for the x-axis, so you want to be very about this, and every time you see a question, you must know what it's asking for and what respect does it want it to. Now we know it's in the x-axis, so we need to get the limits along the x-axis. So in this case, you might have guessed right, you must have the limits 2 and 0. Perfect. So let's actually start doing the calculations. So first off, if we have limits 2 and 0, and we've got this formula y equals 2x plus 1, we know that b is going to be 2 and a is going to be 0, but y squared, we still don't have that. We only have y. So if you might have guessed, you need to get y squared. This is how you do it. So if you have y equals 2x plus 1, what are you going to do? Can you take the square of both sides, so this will equal y squared and you get the right answer on this side? Yeah, sure. So you take the square of that, and you just get 2x plus 1 squared. And mind you, I'm going to go through every single step, so even for the people who have weak math knowledge and weak fundamentals can actually understand what I'm doing. Okay, so you take the square of both sides, and you get something like this, and then you must expand this bracket over here, so you'll get 2x plus 1 and 2x plus 1, and that'll end up giving you something like 4x squared plus 2x plus 2x plus 1, and that'll give you something like, so that'll give you 4x squared plus 4x plus 1. Perfect. You might have been able to do it faster, but as I said before, I want to show every single step, so everyone here understands what I'm doing. Okay, good. Now we have y squared. So if you have a look at the formula, we pretty much have everything, and it's all in respect to x, so now we can actually just chuck this in. Let's have a look. So we have pi, the integral of 2 to 0, because that's our limits, that's b, that's a, that's b and a, and then that's our y squared, so we can just chuck it into brackets, yx squared plus 4x plus 1, and you get something like in respect to dx. See how it says rotated about the x-axis? That means that it's in respect to dx. Cool. Now, let's go further. What we need to do now is integrate this. Integration should have already been learnt beforehand. If not, then I recommend you guys to actually learn how integration works and what it's about, and then come back to this video. Okay. So now when I'm integrating this, I'm going to lay out my square brackets, and I'm going to increase this power, so I'm going to get 4x cubed, put it over the increased power, and I'll do the same for the next few. X squared over 2, and that 1 just turns simply into an x, or you can even say 1x. Okay, cool. So that's my square brackets, and I'm going to close it, and I've got 2 and 0 as the limits. And of course, the most vital thing, you have pi in front. So pi is multiplying by this entire thing. Cool, now let's move on. You've got something like pi, and then it's got a massive bracket, and inside you've got this bracket with subbed in values. So you have 4 times 2 to the 3 over 3 plus 4 times 2 to the 2 over 2 plus 1, 2, 2. Yep. And then that's minusing off, so it's getting subtracted by, well, that is getting subtracted by the 0 subbed into all of these. So let's have a look at that. You get something like 4, 0, 3 over 3 plus 4, 0, 2 over 2 plus 1. So in this case, it's kind of obvious that none of these are actually going to equal out to anything, it's just going to be 0 at the end. But I always do it, just as a principle, just to show you guys. But remember that not every single equation with 0 as a limit, as a limit is gonna be 0. It can also like not be 0 at times. So you must do it just to see, or just think in your head for a second. If you subbed in 0 in all these values, would you actually have anything more than 0 or less than 0? Because if so, then actually use it and do it. But if you're definite that you're not gonna have anything other than 0, then just leave it out. But in this case, I've done it anyways. Cool. So I'm going to sub this into my calculator, and I'll see what I'll get. The aim in this is that you don't actually want to make it in decimal point, and the main reason because of that is that pi, it goes on forever, and like if you round it off, it may not be correct. Even if you round it off, you can round it off, but you must write somewhere that you've rounded it off to a certain decimal point. Okay, cool. So what I'm going to do is I'm going to calculate this part first, and then I'm going to just put pi in it. Okay, so you get, just doing this in my calculator now. 2, 3. You get 3 plus 4 times 2. 2 plus 2. So you end up getting something like 62 over 3. Now we aren't finished, because as I said, I only did this calculation, and you've also got pi multiplying, so you have pi 62 over 3. Now if you even want to like make it neater, what you can actually do is you can say something like, if it's pi over 1 multiplying by 62 over 3, you end up getting 62 pi over 3, and that's therefore your answer. So, and you actually have to have units cubed, which proves to the marker that you actually know you're talking about volume, since it's the solid revolution formed around this x-axis. Okay, perfect. Let's move on to the next example. The next example states, calculate the volume of the solid of revolution formed when the region shown is rotated about the y-axis. Now, if you can remember, I said that you have to have close attention to the question, because that's what's going to actually define your boundaries. Now, y-axis, what does that mean? We're looking at this, and we're going to be looking at this. Perfect. And it's going to be all in respect to dy. So the formula for this is actually different. It's pi, same limits, b and a, but you have x squared instead, and respect to dy. Okay, not bad. So let's end up doing this. We'll just do this now. Okay, so if you have a look, we've got pi integral of 8 to 0, and for the x squared, so if y equals x cubed on the side, because we need to get x squared, remember, so if y equals x cubed, we need to get x on its own first, so you get something like the cube root of y equals x. That looks very messy. We can actually write that as y to the 1/3 equals x. What we can do now is that we need to take the square of both sides. So you get y1 over 3 squared equals x squared. You can simplify that further as y to the 1 over 3, which would just mean y to the 2 over 3, or to 5 over 3. Because 3 times 2, 6 plus 1, 7 over 3. Yep, cool.